This video is about special right triangles. The special right triangle that we're going to talk about in this video is the 30, 60, 90 right triangle. Now this special right triangle comes from an equilateral triangle. This green triangle that I'm pointing to is equilateral. All the sides are congruent. You can see the tick marks. And all the angles are congruent. They're all 60 degrees. Now if I take this vertex and I produce an altitude from that vertex to the opposite side, remember that an altitude in this equilateral triangle is also going to be the median. It's going to intersect the midpoint. That's why these two parts of the side are congruent with the two tick marks. The altitude's going to be perpendicular. So this is 90 degrees. And it's also going to be the angle bisector up here. So we're going to have two 30-degree angles. The 30, 60, 90 right triangle comes from dividing the equilateral triangle in half. Now, one of the things that's really interesting and important about this is whatever the hypotenuse is of the original equilateral triangle, half of it will be the base of this 30, 60, 90 triangle. Remember, all these sides started out the same. So if this side was 6, then this side would have been 6, and half of it would be 3. If this side was 10, this side would be 5. So one of the rules we know about 30, 60, 90 triangles, just because of how they're created, is that the side opposite the 30-degree angle, notice this is the 30-degree angle here, is always going to be half the hypotenuse. That's one thing you just want to remember. The side opposite the 30-degree angle is half the hypotenuse. So we're just going to look at a couple of these 30, 60, 90 triangles and figure out what the height is. Notice we know the hypotenuse and we know one of the legs. We know the shorter leg because it's opposite the smallest angle. So we know that 1 squared plus h squared is 2 squared because we can use Pythagoras here. H squared plus 1 squared is 2 squared. H squared plus 1 is 4. And we're solving for h this time, so we have to subtract 1 from both sides. H squared is 3, and taking the square root of both sides, h is the square root of 3. Okay, if we're going to look for a pattern, we don't have it yet from just one example. So now let's go for the next one where the side opposite the 30-degree angle is 2, and it's half the hypotenuse, which is 4. Again, we're going to use Pythagoras to solve for the height. So the height squared plus 2 squared, in this case, equals 4 squared. The height squared plus 4 is 16. To solve for h, we have to subtract 4 from both sides, and h squared is 12. So, so h is going to be the square root of 12. Now, that doesn't show me a pattern. But if I think about the pattern I had before, I might think, maybe this could be a multiple of the square root of 3. Well, 12 is 4 times 3, so the square root of 12 is the square root of 4 times 3. Using that special property of square roots, the square root of 12, or 4 times 3, is also the square root of 4 times the square root of 3. And since the square root of 4 is 2, 4 is a perfect square, h is 2 times the square root of 3. 2 times the square root of 3. Let's look at a couple more examples and see if a pattern is really emerging. Okay, again, we know that the side opposite the 30-degree angle is going to be half the hypotenuse. So if the side opposite 30 degrees is 3 units, then the hypotenuse will be 6. And using Pythagoras, the height squared plus 3 squared equals 6 squared. The height squared plus 9 is 36, and we have to subtract 9 from both sides of the equation. The height squared is 27. So taking the square root of both sides, the height is the square root of 27. And remember, I'm looking for multiples of 3 here in this pattern. 27 is 9 times 3. The square root of 9 times the square root of 3. And the square root of 9 is 3. So now 3 times the square root of 3 is the height. Let's use a much bigger number. See if the pattern still holds. If the side opposite 30 degrees is 12, that's the smallest side of this 30, 60, 90 triangle, then the hypotenuse will be twice that, 24. And the height squared plus 12 squared will be 24 squared. So the height squared plus 144 is 576. You may know these perfect squares, and that would be excellent, or you may have to use your calculator. Solving for h squared, we subtract 144 from both sides, and we get h squared is 432. And I had to see, was it divisible by 3? Yes, it's 144 times 3. So taking the square root of both sides, well, I might as well go right to taking the square root of this product. H is the square root of 144 times 3, which is the square root of 144 times the square root of 3. And the square root of 144 is 12. 12 times the square root of 3. I've summarized the pattern here. When the side opposite 30 degrees is 1 and the hypotenuse is 2, well, the other leg is the square root of 3. And in each of these cases, we take the side opposite 30 degrees, half the hypotenuse, and multiply it by the square root of 3 to get the leg that's opposite the 60-degree angle, the longer leg. That's true for the smaller numbers, it's true for 12. And even if we didn't know it, even if we just called the side opposite 30 x, well, we could call the hypotenuse 2x because we know that relationship. It comes from the fact that this 30, 60, 90 triangle is half of an equilateral triangle. But if we use these in an equation, a Pythagorean theorem equation, we'll find out that the side opposite 60 is just x times the square root of 3. This is a very important pattern to remember.